It's the universe's ultimate dead end. An object so powerful, it literally eats light. For most of human history, we've seen black holes as cosmic villains, the final, violent punctuation mark at the end of a star's life. They're a place from which nothing, not even information, can ever return. The monsters lurking in the dark between the stars. But what if that's just wrong? What if the most destructive force in the cosmos is also the key to humanity's ultimate survival? The blueprint for powering a galactic empire. This isn't just sci-fi speculation, a theory first dreamed up over 50 years ago by one of physics' greatest minds, Sir Roger Penrose, describes how to turn these cosmic monsters into the most efficient power plants in the universe. It's a concept buried deep in the dizzying mathematics of general relativity, a plan that would let a civilization harness energy on a scale that would make entire stars look like flickering candles. It would be the power source of gods, and this is how we would build one. To understand the future, you first have to understand scale. Back in 1964, a Soviet astronomer named Nikolai Kardashev came up with a way to measure how advanced a civilization is, based on the one thing it will always need more of: energy. A Type 1 civilization, he said, could harness all the energy on its home planet. That's every drop of sunlight, every gust of wind, every single split atom. We are not there yet. By most estimates, we're currently wallowing at a Type 0.73, still mostly burning the fossilized remains of ancient plants and animals. A Type 2 civilization would be far, far grander. It would be able to capture the entire energy output of its home star. Picture a colossal megastructure built around our sun, a Dyson sphere, collecting every last joule of its immense power. With that kind of energy, a civilization could rearrange its own solar system, move planets, and power computers so vast we can barely imagine them. But even that has limits. The sun will eventually die. And for a truly galactic empire, a Type 3 civilization, you need to think bigger. A Type 3 civilization would control the energy of its entire galaxy, the light of billions of stars, and then some. To make that leap, you don't just need more stars. You need a better engine. You need something that makes a star's power look pathetic. This is the great problem for any civilization thinking about its long-term future. Growth needs energy. But the universe's most obvious power sources, stars, are ultimately finite and surprisingly inefficient. Nuclear fusion, the engine that powers the stars, only converts about 0.7% of its fuel's mass into energy. It's powerful, sure, but it's also wasteful. For a civilization with ambitions written across spiral arms and galactic voids, there had to be a better way. The answer, paradoxically, was found inside the very object that seems to be the opposite of energy: the black hole. And not just any black hole. It had to be a spinning one. When a truly massive star dies, its core collapses under its own crushing gravity, squeezing down to a single point of infinite density, a singularity. Around this point is the event horizon, the famous point of no return, where gravity is so strong that the escape velocity is faster than the speed of light. You cross that line, you're not coming back. For a long time, that was the whole story. A simple, non-rotating black hole is a pretty boring object. It has a singularity and an event horizon. It's a cosmic jail. But the universe is rarely boring. It spins. Stars spin. Planets spin. Galaxies spin. And when a spinning star collapses, it creates a spinning black hole, an object known as a Kerr black hole. A Kerr black hole is a much weirder and more interesting beast. Its spin is so powerful that it literally drags the fabric of space-time around with it. This effect, known as frame dragging, creates a bizarre new region just outside the event horizon. It's a place where space-time itself is being swirled around like a cosmic whirlpool. This region is called the ergosphere, from the Greek word ergon, meaning work. And it is aptly named because from this region, work can be extracted. Imagine getting close to that massive whirlpool. Far away, you can swim wherever you want. But the closer you get, the stronger the current. Eventually, you hit a point where no matter how hard you fight, you're going to be dragged along. The ergosphere is the cosmic version of this. Once you enter it, you have to co-rotate with the black hole. You can't stay still because space itself is moving. But, and this is the crucial part, unlike the event horizon, you can still escape. The ergosphere is a cosmic dance on the very edge of oblivion, a place where the rules of reality start to get very, very strange. And it was in this strange, swirling dance that Sir Roger Penrose saw an opportunity. In a 1969 paper, he laid out a thought experiment that would completely flip our understanding of black holes. He realized that the incredible rotational energy of a Kerr black hole isn't all locked away. It's stored in the twisted space-time of the ergosphere, and it could, in theory, be tapped. He had found a way to make the monster work for you. He had conceived the Penrose process. The Penrose process is both brilliantly simple and mind-bendingly difficult. At its heart, it's a cosmic heist. The target, the black hole's spin energy. The tool, a disposable projectile. Here's the game plan. You start with an object, let's call it a work body, and fire it on a perfect trajectory into the ergosphere. Once it's inside this swirling vortex of space-time, the work body splits in two. Piece 1 is designed to be sacrificed. It gets thrown on a very specific path that takes it across the event horizon and into the black hole. Now, here's the trick. This piece is engineered to have what physicists call negative energy. It's a relativistic loophole. From the perspective of someone far away, because of the particle's unique motion against the extreme frame dragging, its total energy is calculated as negative. So, when the black hole swallows this particle, its own total mass energy actually goes down. Think about the conservation of energy. If the total energy of the system has to stay the same, and the black hole just lost energy, then that energy had to go somewhere. It goes into Piece 2. Piece 2 is your payload. It's fired on an escape path, flying back out of the ergosphere. But because its twin just delivered negative energy to the black hole, Piece 2 escapes with more energy than the original work body had to begin with. The extra energy didn't come from nowhere. It was stolen directly from the black hole's spin. The black hole slows down an infinitesimal amount, and your escaping piece flies away supercharged. In a perfect scenario, this method could extract up to 20.7% of a particle's mass energy. Compare that to nuclear fusion at 0.7%. In total, a civilization could theoretically extract up to 29% of the rotational energy from a maximally spinning black hole. While nature has other ways of getting energy from black holes, like the Blanford-Znajek process, which uses magnetic fields, the Penrose process is the classic blueprint for how a civilization could do it deliberately. So how would you actually build this thing? This would be the greatest engineering project in history. First, you'd need a target, a supermassive, rapidly spinning Kerr black hole, hopefully in a quiet part of the galaxy. Construction would likely start at a safe distance, using fleets of self-replicating robots to mine nearby asteroids and moons for raw materials. Those materials would be used to build a vast ring or a partial sphere orbiting the black hole, well outside the deadly chaotic accretion disk. This wouldn't be a solid shell like a classic Dyson sphere, but a massive, orbiting industrial complex. Some scientists have nicknamed this idea an inverse Dyson sphere, a structure built to capture energy radiating from the black hole's environment. This structure would be a non-stop factory. One part would manufacture the work bodies. Another section would house colossal electromagnetic catapults, precision-engineered to launch them on that perfect trajectory into the ergosphere. Then comes the hardest part, the collection grid. As the supercharged Piece 2 particles blast out of the ergosphere, they'd be caught by a vast network. Maybe they're charged particles caught by immense magnetic fields that convert their kinetic energy directly into electricity. Or maybe they slam into a target, transferring their energy as heat to drive incomprehensibly huge generators. The power generated would be monumental, dwarfing the output of our sun. This energy could then be stored in moon-sized battery arrays and broadcast across the galaxy using powerful laser beams, powering colonies thousands of light years away. With a working Penrose power plant, the Kardashev scale becomes almost quaint. This isn't Type 2 or Type 3. This is something else entirely. Energy would become, for all intents and purposes, free. And what would a society do with that kind of power? It's not just about keeping the lights on. This is cosmological scale energy. Fleets of interstellar ships could cross the galaxy with ease. Planets could be terraformed in decades, not millennia. Entire stars could be moved and their resources harvested. A civilization could literally create and sustain new worlds. The computational power would be equally godlike. They could build Matryoshka brains, nested supercomputers around the power source, capable of simulating entire universes or answering questions we don't even have the words to ask yet. It would be a true golden age, a galactic empire built not on conquest, but on creation. But this unimaginable power comes with an equally unimaginable risk. The power plant is a sword of Damocles hanging over the entire civilization. It's the ultimate single point of failure. The engineering is beyond Herculean. The collector ring would have to survive constant bombardment by high-energy radiation. No known material could withstand that. The gravitational forces would be monstrous. The tiniest miscalculation in an orbit could cause a catastrophic failure, sending tidal waves of gravitational energy through the system. One tiny engineering flaw wouldn't just cause a blackout. It could lead to the annihilation of the entire megastructure. A civilization that builds its future around a black hole lives with the constant knowledge that its source of infinite power is also the universe's most efficient destroyer. They would need a level of technological and social maturity to match, an ability to maintain a project over geological timescales. One political collapse, one dark age, one forgotten maintenance check, and their entire empire could be extinguished, consumed by the very engine that gave it life. The Penrose process transforms a black hole from a cosmic graveyard into a cosmic engine. It shows us that even in the most extreme corners of the universe, the laws of physics provide a path to creation. The idea, born in the mind of Roger Penrose in 1969, is still theoretically sound. In fact, scientists have managed to demonstrate the underlying principle in labs using clever analogs with sound waves and rotating water. It's not a fantasy, it's a remote possibility. For us, today, it's a profound thought experiment. Building it is fantastically beyond our reach, but the theory itself forces us to look to the deep future and ask big questions about our own destiny. The path to becoming a galactic civilization isn't just about better rockets. It's about energy. It's about having the wisdom to harness power on a scale we can only dream of. The Penrose process is a potential blueprint, a door left ajar by the laws of physics. It represents the ultimate test for any species. A choice to stay bound to our cradle planet and our dying star, or to reach out and tame the monsters of the cosmos, turning them into the architects of our future. It's a choice between safety and godhood. If humanity survives long enough to face that choice, if we one day stand at the edge of a spinning black hole with the tools to build this engine, the real question won't be about physics or engineering. It will be about our own character. If we could build it, should we? What do you think? Is near infinite energy worth the immense risk of building next to a black hole? Let us know your thoughts in the comments.